If you have your bird beak activity reflection done, please hand it in. Get it out, hand it in. First things first, hand in your reflection on the activity that we did yesterday. It's counting as a lab grade for you. In the bin as well. Yeah, if you got dragons or monsters or anything that you haven't, like 3 or 4 biology activities, hand it in. You don't have to wait for my permission. Just get it and throw it in the bin. You guys are block D. Okay. And then find me this page. It's got the tigers on it. We're going to talk about tigers. Not really. They're there. The tigers are there, but we're not really going to talk about them. Okay. So we were outlining our natural selection yesterday. Massey, have a seat. We defined it. We defined natural selection, the process by which characteristics of a population change over many generations as organisms with heritable traits survive and reproduce, passing their traits on to their offspring. We defined this more simply as survival of the fittest. And then we ended class yesterday just kind of discussing what fittest actually meant. Fittest doesn't mean what you typically think of when a Western human population says fittest. It is just fittest in the most general sense is just whatever the best traits are for a particular environment. And who knows, maybe in the Western world, the six packs and the biceps are the best way to pass on your genetic material. I don't know. I don't have those and I have 2 kids, so it worked out for me. But whatever fittest looks like in a particular environment. So we're going to go through some principles of natural selection today, and if we've got time, we're going to look at artificial selection today as well. And I'm going to show you guys some horrifying pictures of dogs. So let us go. Number 1, because we have done it to the dogs, and so we're going to look at what we've done. Yes. We're going to look at what breeding we have done has done to their skeletal structure. We're going to look at pictures of pug skulls and why those dogs should just all be put out of their misery. Pugs should not exist because their whole existence is suffering. We're going to look at pictures of why that's true. So, natural selection. Principles of natural selection. Number 1, in order to have selection of different heritable traits, there must be genetic variation. And what do I mean by variation? If you had to explain variation in simpler words, what would you say? Differences, different what? Specifically, what kinds of things? We're talking about genetic variation, so there needs to be different. Yes, different things of one thing. Yes, I know what you mean. Let's take that and amp it up just ever so slightly to use the biology terms that we've got here. Sorry? Well, I don't use the word variety because that's what we've got here. You've got the idea, but the language is lacking. So I'll give you the language. Different expressions of traits, I think is what Brooklyn was getting at. You have different, like the same trait exists, like these tigers. That's a black and white picture. It's not a great picture. Here's the colored version of that same picture. You have, there's a couple different traits here that we can look at. Color of fur. That one's basically all white. That one's white with more defined stripes. These are 2 different colors of orange. There's variation in these tigers. And different animals can have different versions of those same traits. You can have giraffes with different lengths of neck. You can have, why is that the thing I'm hung up on? You can have variations in strength in a species. You can have variations in intelligence of a species. Whatever those traits are, we need to have different expressions of them. If they don't have variation, you're not going to have natural selection. Either the population will survive or everyone's dying out. It's the problem we have with bananas right now. Because bananas globally are genetically identical. All of them. They are all genetically identical, which is bad. Because if a disease develops that wipes out bananas, all of the bananas will be impacted. Yep. That's a great question. Because there is something to do, like, I mean, plants are more than their, just like you are more than your genetic material. You can have genetically identical twins that look different. Mary-Kate and Ashley Olsen look different, but they're genetically identical. There's impacts of the environment on, there's the nature versus nurture environment, the genetics versus how you were raised. I don't know how many Mary-Kate and Ashley movies there are where the whole point of the thing is that they're genetically identical, separated at birth. One ends up rich, one ends up poor. They meet each other at summer camp. No, absolutely not. Because I was made to watch that too many times as a child by my sister. And I'm not bitter about it or anything, but we're not watching it. So, when we're talking about these different traits, often what we talk about are these: adaptation. So an adaptation is I've got 3 examples of adaptations. I feel like this sentence should actually be up above, and then this should be below, and I oopsed that, my apologies. So an adaptation is a trait that improves an organism's chance of surviving and reproducing. And so it's these adaptations that you can have different kinds of that will either make it easier or harder for an animal to survive. One of the examples that we've mentioned is like fur color on rabbits. That was quick. See you guys later. Swimming? Okay, just today. Yeah, see ya. Yeah. Oh, you got my protractors? I don't need them. You can hang on to them till tomorrow. But perfect. I totally lost my train of thought. That's okay. Yeah, we're talking about adaptations. Bunny fur. Thank you, bunny fur. So, like, there's different fur colors in different species. When I showed you guys, I did tell you that I'm not going to make you learn the dihybrids, like the hybrids of multiple traits. But one of the things that showed up there was we talked about how populations of rabbits, black is a dominant fur color, white is a recessive fur color, but in certain circumstances, the recessive one is the one that actually dominates the expression in the environment, because if you live in a snowy area, having black fur is actually a detriment to your survival. Having white fur helps you blend in and to survive. So even though it's a recessive trait, it's the trait that's going to show up in a population because all the black bunnies died. Because black bunny in the snow is going to get seen from a mile away, at least. So there are different kinds of adaptations. We're going to go through the 3 kinds of adaptations. Give me an example of an adaptation. And I will give you the kind of adaptation that it is. Preferably not. Which one were you going to use? Okay, so the example that you just gave me is changing fur depending on the species. Okay, cool. So that particular kind of adaptation is called a physiological adaptation. Physiological, physiological. And a physiological adaptation is defined to be an internal response to an external stimulus. And there's a lot of language there, but I think the example that you just gave is a really good one. Different kinds of fur coats depending on season. But this is the kind of the changing coats is the one I want to hone in on, because that's a really good example of a physiological one. The internal change to an external stimulus, depending on the time of year. My cat's doing this right now, which is awful because I don't brush her as much as I should, and so then she throws up these massive hairballs because she's losing her winter coat and getting her summer coat, and I don't brush her like I should, and so these massive hairballs show up because she's trying to clean the long fur out because it's getting hot. That's a really good example. There are, yes, Sarah. Chameleons would fit here too. That was going to be my next question. Can we think of other examples? Chameleons are a great example. What is the external stimulus to your chameleon example? So the internal response is to changing color. Why do they change color? Why would they ever need to do that? Protect themselves from predators. So the internal response is the color change. The external stimulus is the presence of a predator. Same thing with octopuses and squids. They'll change their color. The internal response is the color change. The external stimulus is the presence of a predator or the presence of prey. Yes? What's the question? Say that again. There's always more of a prey population than a predator population. Because if you have too many predators, then the predators will eat all the prey and the predators will starve to death. So the way the world balances, if something's preying on a chameleon, there will always be less of the predator. Just otherwise, the whole population crumbles. So those color change is a really, really good example. Color change, fur change, really good example of a physiological adaptation. Another example of a physiological adaptation is you guys. You guys are warm-blooded. Mammals are warm-blooded. I believe birds might be too. I can't remember the bloodedness of birds. Say have you in biology? But you guys don't do vertebrates. You're in grade 11. Warm-bloodedness means that your body can regulate its temperature depending on what's going on outside. If you're cold, you shiver. You shiver to warm up your body. If you're hot, you sweat. You sweat to produce a layer of water that takes heat out of your body, decreasing your overall temperature. Not all animals have that adaptation. Thank you, Mahip. Some animals are cold-blooded. If you are a cold-blooded creature, thanks, Mahip. Thank you. Hey, happy to help.
We're out for the day. We'll go do our stuff.
Peace. Yeah. If you're cold-blooded and you want to warm up, what do you have to do? If you're a lizard who's cold, what do you have to do? To warm up, what do you have to do? You have to find a heat source. Lizards can't shiver. Their temperature of their blood is dependent on the temperature around them. So if they are too hot, they have to find shade. It's an and most fish are similar. It was a really big deal, actually, to find species of fish that are warm-blooded. That was a big deal. An example of a warm-blooded fish would be a great white shark. Great white sharks are warm-blooded. They can regulate their body temperature regardless of the temperature of the water around them, which is not many fish can do. That adaptation is a big deal. We take it for granted, but it's there. Okay, give me another example of an adaptation. Someone said, Brooklyn, you said just being in possession of fluffier or not fluffier. So ignoring the changing of the fur. You're really into fur today. Both of your yes. The shedding is physiological. Yeah, the shedding is a physiological, and it's getting on you. Yes. Okay. For those of us who are not overly familiar with horses, I'm just going to extend the example into dogs and cats. Like you can have your Persian that's super fluffy, your Siamese that has really short fur, the Sphinx, which is that ugly cat with no fur. Dogs are similar. Like there are species of your Jack Russell Terrier, really short fur, does great in this environment. Then you've got your Huskies. Your Huskies should not live down here. It is unkind to the Husky. Even when the Husky sheds, they have this thick fur coat. That kind of example is what's called a structural example of an adaptation. Yeah, because she's desperately trying to get rid of fur. A structural adaptation is how an organism is built. So forget the changing of a trait. This is just how an organism is. Huskies will always have thick fur coats. Cats, most cats, almost all cats, can retract their claws. One species of cat cannot. Does anyone know the species of cat that cannot retract their claws? Nope. It is way more commonly known than what is Turkish. Sorry? Nope. It's one of the big cats. No, the cheetah. Cheetah cannot retract claws, for example. You said it, but then didn't say it? The cheetah is the one big cat that cannot retract its claws. Why is that important? No, it's not their fighting. It's the other thing that cheetahs are known for. Their speed. They need those claws. It's the way they accelerate, the way they turn, the way their whole thing is speed. And so they are 100% built for speed. Other cats are hunters. They hide. They retract the claws so they can be quiet. Listening to a cat walk around and listening to a dog walk around are very different. Dogs walk around like this. Cats walk around like this. The padding is very different. Until the cat's pissed, then all of the claws come out. Cheetahs don't need that. Cheetahs just are built for speed. And so they're like, it's like having cleats on. The claws are always out. So structural adaptation is how an organism is built. Things like, the example that I'll give you are things like claws, the presence or lack thereof. What other examples do I have here? I don't know. Let's go owls. Owl's feathers. Has anyone ever heard an owl fly? I'm willing to, really? Did you hear the owl fly or did you just see it? And you didn't, then it wasn't an owl. The whole point, the reason I bring up owls is because you don't. If an owl is flying around, you will not hear it. Unless it's something going horribly, horribly wrong with the owl. Generally speaking, you might hear the air rustle, but you won't hear the bird. As opposed to like a hummingbird, you can hear it buzzing as it just kind of flies there. And owls have a structural adaptation to be effectively silent as they fly. So we got structural, we got physiological. There is one more class of adaptation. Someone give me another example that does not fit into either of these two, and maybe we'll find the one that does. Like what? Hibernation's physiological. What? You could make an argument that it's this one I'm looking for. Could you make an argument? Okay, then yes. We're not going to call it a psychological, but that is the class we're going for. We're going to call it behavioral. A behavioral adaptation is what an animal does. How it goes about its business. So the fact that dogs are inherently pack animals. They like the presence of other dogs, generally speaking. They pack. Or that a skunk can spray or that an octopus can, like that they do these things, is an example of a behavioral adaptation. You're taking notes here, yeah? You're doing this with me too? Okay, so these are all examples of the stuff that we're talking about. That is the first thing that needs to be present. Variation within traits, and those traits are often this list of adaptations here. Number 2, there needs to be some of the variations are favorable. No, it means beneficial to the animal. Like the white fur on bunnies is recessive, but it's favorable in the snow. So I'll use that as the example. White bunny fur versus black bunny fur in snow. This one is dominant. This one is recessive. But this one is favorable. Because of that fact right there. I keep harping on the same example because it works for so many things. Organisms that have an advantageous mutation may survive better in a changing environment. Again, this all comes back to the mutation stuff that we talked about last week. When you're ready, flip the page. And we'll talk about number 3. So the first, we have steps in natural selection. The first one is variation. The second one is favorable variations. The third one is more offspring are blank than can survive blank. More offspring are produced than can survive, and this blank doesn't need to be there, it's just period. You get a ton of offspring that are produced, more than are going to just survive on their own. The offspring that do survive have the favorable traits. And if the offspring that are surviving are only the ones with the favorable traits, then you're going to get a population that will change over time. And that was the whole point of what we did yesterday. And for those who weren't here, what we did was I split the class up into 4 groups. Each group got a different kind of beak, and Sahib scattered beans on the ground. We saw what happened as time went on, generations passed, of those birds eating the same food source. The birds with the tweezer beaks and the clothespin beaks died out because the spoon beak and the fork beak were more advantageous given the chosen behaviors of the birds. And so you get, over time, the population of our little island, our room, changed. The tweezers and the clothespins died out very quickly, and the fork beak and the spoon beak survived. So population is going to change over time. Environmental factors select for certain characteristics in some individuals and against other characteristics. We looked at one specific example yesterday with the beaks. Over a very long time, the population changes. Because individuals with favorable characteristics survive and reproduce, while individuals without them die. The environment, we talked about this yesterday, but the environment exerts selective pressures. There's different kinds of selective pressures. The environment exerts selective pressures that result from a few things we didn't talk about yesterday. This blank down here is the one that we did. We looked at competition for resources. There was a limited amount of food that you could eat. Sorry? Strength? No. So these resources, these limited resources are a whole bunch of these things add up together. I mean, strength is an adaptation. If you happen to be stronger, maybe you can outcompete. But we did see yesterday that certain degrees of outcompete, like certain degrees of aggressiveness, you were too aggressive. You, Evelyn, were too aggressive in your competition for beans, you died. Savrit was not aggressive enough and so died. So how the competition has, so limited resources, we're talking about things like food and space, how you compete, and a lot of these adaptations that we're talking about are all related to competition. I shouldn't say all. A lot of them are related to competition. Selective pressures that relate or that result from predation. These are the things like the chameleon can change its color. The rabbit is white. I don't know. Those kinds of adaptations. Things that make it easier for you to survive being hunted. These are the adaptations that allow you to hunt better. And this blank right here is disease. The environment exerts selective pressures that results from predation, diseases, and competition. I can't think of anything that doesn't fit into one of those three categories. Organisms that have a particular trait are more likely to survive diseases, or other traits are more likely to survive predation, or other traits are you're more likely to survive going out and getting food, defending your space. And then natural selection is, the other piece to this, is that natural selection is situational. A trait that may be I'll say that should be the word an, not a, an advantage to an individual one time might be a disadvantage to its survival later on. So yesterday with the beaks, spoon beaks, fork beaks survived. The tweezer beaks, clothespin beaks died out. But if I had changed it, we did that for a couple more rounds, and then I changed the food source on you. If I gave you something different, I don't know, what would be hard to eat with a spoon or a fork that would be easier to collect with tweezers? Yeah, maybe. Or spaghetti. If I gave you like hard spaghetti, it'd be harder to get that onto a fork or a spoon. But it'd be easier to tweeze or clothespin. I don't know. Maybe I gave you something living to catch. Bugs. I release a horde of bees. Good luck spooning bees into a cup. But if you had tweezers, you could tweeze bees into a cup. Right? Spiders. Right? Like if I had changed the food source yesterday, we could have created a scenario where all the spoon beaks and fork beaks died out immediately because they couldn't collect anything. So, oh, sorry. Hornets. Yeah. So an example would be something like, there's a lot. I want to see if I can condense my example. There's a lot of writing otherwise. A woodpecker. Here's my example. What is the woodpecker designed to do? Why? To get food. There's insects in the trees it wants to eat. What if those trees die out? So it drills into trees to eat bugs. That's why it has the beak that it does. If the trees die out, or the bugs leave, or the bugs die, how do bugs avoid what? Bugs are stupid. No, they try and run. They fly, they run. They're decomposers. No, there's a purpose to the worm. Not what we're talking about now. There's a purpose to the worm. They're decomposers. Woodpecker drills into the tree to eat the bugs. If the trees die or the bugs die, if the food source changes, the woodpecker may be unsuited. Believe me or not, this is actually less than what I'd written before. To new food. And if the woodpecker can't eat, the population either leaves or the population starves. Okay. And in some cases, natural selection has been shown to lead to the formation of a new species. This is where natural selection, something that we see in the environment all the time, and the theory of evolution start to connect. And we've seen this happen in small ways. Natural selection can lead to the formation of new species. This is called speciation. Species are defined as individuals of the same species can interbreed to produce fertile offspring. If they can do this, they are part of the same species. There might be subspecies within a bigger species, but overall, one of the definitions of a species is a population that can interbreed or breed with each other to produce fertile offspring. Some members of a population change so much that they are no longer able to produce fertile offspring with members of the original population. This leads to speciation when new species are formed. So, an example for you. Zebras and donkeys. Zebras and donkeys look similar, yes? They look, yes, forget the stripes on one of them. Like physically, they just look like you took a horse and you changed it a little bit. Zebras, like size-wise, zebras and donkeys are similar in size, similar in structural appearance. But if you take a zebra and a donkey and you breed them, you make something called a zonkey. And a zonkey cannot reproduce. You cannot make zonkies. So so this is an example of what we're talking about here. Zebras and donkeys may have had a common ancestor, but the adaptations have separated them so far down the chain that in some areas the zebra was better suited, in other areas the donkey was better suited, and now you have populations, these two, even though they may have shared a common ancestor at some point in the past, cannot breed with each other to create fertile offspring. Zonkies cannot reproduce with other zonkies because of those chromosomal issues. Evelyn, does that answer the question? Okay. When you're ready, flip the page. This is the last page for today, and then I'm done. I know I've talked to you today way more than I've talked to you yesterday. Okay, here we go. Last page. One type of speciation is something called adaptive radiation. This is like the classic example that Darwin started with when Charles Darwin wrote his book, The Origin of the Species, and started throwing down what he called his theory of evolution. Adaptive radiation was the big example. Here's how adaptive radiation works. Adaptive radiation is the diversification of a common ancestor into a variety of different adapted species. The big example that Darwin, I don't know if you guys are aware of the history of Charles Darwin. Charles Darwin was on a ship that was during the period of great exploration, and he ended up on a small island chain off the coast of Ecuador. Does anyone know what this small island chain off the coast of Ecuador is called? It's like the greatest. I have huge dreams and desires to get to this location. No, I've been there. It's also awesome, but no, Hawaii is not off the coast of Ecuador. Starts with a G. The Galapagos. He ended up, and it's also right here. He ended up on the Galapagos Islands, and on these islands were rich in biodiversity, really cool species. And one of the things that he saw was that there were finches on the Galapagos Islands, and these finches have different beak shapes due to their diverse diets. They are all finches. Bird species-wise, super like the hierarchy species, they're all finches, but depending on where they are on the island, they have all adapted to, on the set of islands, they've all adapted to different food sources in different regions on those islands. And if you took a bird from, and it's gotten to the point where if you take one of the finches of one species from one location to the other, a different location on a different island in that chain, it will die. Because, I mean, look at the beaks here. You have these kinds of birds that are designed more for nectar. These kinds of birds that are, this kind of bird that's designed for probing insects. This one's kind of a cross between, this one's a cross between these two. But then you've got ones that are, this beak is obviously thicker than this beak. These ones are designed for crushing seeds. This one does seem to be a hybrid of the two. And you've got, if you asked this bird to go eat nectar, like this bird, it probably couldn't do it to near the same degree. Or this one versus this guy. This guy can reach insects, this guy never could. So he theorized that the selective pressure would be the kind of food available to these different birds. And what resulted was a singular species of finch that, put your phone away, Massey, that has become this diverse collection of different subspecies of finch due to food source. Another example is the tortoises. Tortoises on the Galapagos Islands are all different due to mutations, natural selection, and adaptive radiation. Depending on where they are, they look different. This tortoise, definitely different. Here's the color version to make it easier to see. You can see cell structure or shell structure is very different. This guy here versus this guy here. I don't know enough about tortoises to know why they have separated out like this, but I know that they have. If a species is unable to adapt to its environmental pressures, it is possible for every member of that species to die. And if every member of a species dies, what do we call that? Extinction. Extinction can happen naturally. It doesn't always, and it's less likely to happen naturally. It's more likely to happen because we did something stupid. Like the dodos we hunted to extinction. Or there used to be grizzlies in California. There used to be grizzlies in Mexico. Mexico used to have a massive grizzly population. You're not going to find a grizzly in Mexico anymore. That species of grizzly bear has been wiped out. Overhunting due to Spanish soldiers. It did. There are cold mountainous regions of Mexico. And there was a massive grizzly population in Mexico, California, Nevada, that area. And then no longer, they were hunted to death. I don't know anything about, I don't know about Chile. Chile is sufficiently far away from Mexico and California that I can't speak to Chile. Okay. That's all for me today, I think. I got some stuff I want you to play with. So you got a natural selection worksheet and some natural selection questions that I'd like you to start taking a look at here. Everything is fair game, and you've got lots of time to do this. From here, I would like you to go. There's a lot of reading here. Oh, boy. Try this guy. Yeah, I want you to take a look at this stuff all the way out to the page here called artificial selection. This is what we will look at tomorrow. All the way to there. Homework from here up to artificial selection. And you guys are going to do a lab for me on Friday. Yeah, it's going to be good. Okay. Your time is yours. You've got what you need to work on your market set giver.